Good day, boys and girls.
Yes.
It's time for chemistry. Today we are going to have chemistry. And the topic for today is water and solution. Water and solution. We are used to water, but today we are going to look at water in chemical way with perspective on chemistry. I expect you, at the end of this lesson, to be able to list different sources of water. Take that in mind. I will also want you to know the components, elements in water. At the same time, you should be able to give evidence that supports that water is made of hydrogen and oxygen. While I also want you to know the physical properties of water. You should also be able to give examples of treated water. You should also be able to identify quality of water that is suitable for drinking at homes. In the same way, you should be able to list the processes that is involved in treating water. Finally, you should also be able to describe how to treat water for drinking. But during the course of this lesson, we'll be looking at some keywords. So bear this in mind. And the words include water, aeration, coagulation, sedimentation, filtration, disinfection, alum, distilled water, deionized water. And we'll also look at the Hoffman's photometer, combustion, and what is water cycle. But before we go on, I would like you to take your pen and write in 20 seconds anything you know about water. Ask yourself this question: what do I know about water? It's always important when you want to start a lesson, when you want to learn a new subject. Ask yourself what you know about water, and please write it down for the next 15 seconds. Anything. Now, having done that, what do you want to learn about water? What are you expecting me to teach you concerning water? What do you want me to tell you? Please quickly do that in 20 seconds. I will go around and check your notes to see what you have written down. Thank you. Now, let us go to the lesson proper. Having seen what you intend to learn and what you know already, let us now go to the lesson. Water is so common, it's everywhere. But water is a universal solvent because it can dissolve almost all substances. That's water for you. Almost all substances that you see around you are soluble in water to some extent. Even glass is soluble in water. It's just that the solubility is so small. Palm oil is soluble in water to some extent. Sand is soluble in water to some extent. So water is a universal solvent. It can dissolve almost all substances. Any substance that's able to do this one is called a general solvent or a universal solvent. And water happens to be that. Then at the same time, water is an hydride of oxygen. That is, it's a compound of oxygen and hydrogen. Take note at the same time that water is also an oxide. Oxide of what? Oxide of hydrogen. Right, it's an hydride of oxygen. Now, on this page, so far, we have learned three things. Water is a universal solvent. Water is an oxide. And water is also an hydride. What are the components of water? What are the chemical elements present in water? Well, chemically, there are evidences that shows that water contains oxygen and hydrogen. The formula of water is H2O. It's not an accident. It's not just a cook-off. there were reason why the formula of water is H2O. And there are two evidences for that in chemistry that we can show. Number one is combustion. When you take oxygen and water and you burn it together, it always produces steam. When you take the steam and you cool it down, it turns to water. So combustion of hydrogen and oxygen always produce water. That is number one evidence that water is a compound of hydrogen and oxygen. The second evidence is that the same water, when you take water and you pass electric current through it, it breaks the molecule of water into two gases, hydrogen and oxygen. That's the second evidence. So the two evidences are combustion of hydrogen and oxygen, and two, electrolysis of water, which brings water into hydrogen and oxygen. Now, to explain that further, what you have here is known as the Hoffman photometer. And this is a DC battery. The cathode, the anode, connected to the Hoffman photometer. From here, water is poured inside this apparatus, and then the tap there closed. Now, the electric current passes through, and then breakage takes place. In the cathode, hydrogen is produced, and the anode, oxygen is produced. But if you check the volume of hydrogen produced here, and the volume of oxygen produced, you see that two volume of hydrogen is produced, one volume of oxygen is produced. The volume of hydrogen here is twice the volume of oxygen. That means the formula of water is 1. Yes, because the volume of hydrogen produces twice that of oxygen. Two volume of hydrogen, one volume of oxygen. That's why the formula of water is H2O. In the second picture here, you can see hydrogen and oxygen burning and being cooled to form water. That is the second evidence. This is combustion of hydrogen and oxygen to produce water. So the two evidences are combustion and electrolysis of water. Now, let us look at the properties of water, the physical properties of water, to be precise. Every one of us knows that water is colorless. But water is not white, it's colorless. It has no color. But water is not tasteless. Actually, water has an insipid taste. It has a satisfying taste. So, and the specific gravity of water is 1 gram per cubic centimeter. What does that mean? It simply means that if you take 1 gram of water, it will occupy 1 cubic centimeter. Or if you take 1 cubic centimeter of water, it will weigh 1 gram. So these are the properties of water. It's colorless, it has an insipid taste, and it has a gravity of 1 gram per cubic centimeter. Now let us look at natural water. What is the source of natural water? What are the sources of natural water? There are many. Rainwater, we have spring water, we have well water, we have lake, and then we have sea. If we even have water in the rivers. This is the sea. Look at cloud, rain falling down, the water will run off, go into the gutter, go into the stream, then eventually the lake, and probably end up in the ocean. Now, out of all these sources of water, the primary source is the sea. The sea is the primary source of water. Look at the earth. If you have seen the globe of the earth before, the earth is made up of 75% of water and 25% of land. So the world is sitting on top of the ocean. So the ocean is the main source. And the funniest thing is that all these sources of natural water, they are connected together. Whether it is a river, the stream, the spring, the well, the river, and the ocean, they are all connected by a cycle that is called water cycle. How? Look at the sun. The sun shines on the sea or on the water body. whether it's on the river, the well, the lake, and then the water evaporates. The evaporated vapor rises up from cloud. The cloud, when the temperature is lower than usual, precipitates and rainfalls. The water run up, go into springs, into streams, into rivers, into lake, and eventually go back to the ocean. And then evaporation takes place again. Condensation, cloud formation, precipitation, rainfalling. The cycle continues on and on. This is water cycle. Water cycle is a process that connects all the sources of water together by process of what? Evaporation, condensation, and precipitation. Therefore, the sea is the main source of water. Rainwater, of course, we all know rainwater. Nigeria is in the rainforest, and then we know some parts of Nigeria is in the rainforest, and we know that rainfall regularly. Then, the rainwater is the purest form of water. It's the purest form of water because it is formed by condensation when the water evaporates. The impurity in water will not evaporate, it is only the pure water will evaporate, rises up, and fall down. So rain remains the purest form of water, simply because it is formed by condensation. And let us look at treated water. It's not all the sources of water that you see that is good for our use. Some are not. For instance, you cannot just go to the stream and collect water and be drinking it. You cannot just go to a pond and collect water and be drinking it. Sometimes we need to treat water, and there are different forms of treated water. We have 4 examples here. The first one is called distilled water. We have deionized water, pipeline water. We also have chlorinated water for swimming pool. But first, let us look at distilled water. You know kettle? How many of you know kettle? Yeah, we use kettle in our homes. If you put water inside the kettle and you boil it, the water will turn into vapor. That vapor that is coming out can be cooled down by a device known as condenser. When you cool it down, it forms water. The water that you get from it is the purest form of water in the world. That type of water is known as what? Distilled water. Water that has been distilled by the process known as what? Distillation. You heat the water boils, turns to vapor, you cool it down. That is called distilled water. And the next one is deionized. In this one, we use chemical. We use chemical substances to remove ions that are present in the water. Maybe magnesium ion, calcium ion, sodium ion, chloride ion, ion 2 ion, ion 3 ion. This ionizer, or what we call deionizer, usually known as resin, they remove it, and then the water is not distilled water, but the water is what? Deionizer, or deionized water, because you are using deionizer to remove it. And the next one is pipe-borne water. That one is quite common in our homes. The one that government pump from water works into our various homes that we use in our bedroom, in our kitchen, and we can drink it because it is safe, it has been treated. The next one is chlorinated water for swimming pool. In swimming pool, you normally add chlorine to it in order to kill the germs there. So these are the treated water, form of treated water that we have. Next, this is a swimming pool. The color is blue. Why is the water in swimming pool blue? Why is the water blue? Because copper sulfate solution is added to swimming pool. Copper sulfate solution is a blue solution. Yeah. So, and the function is to prevent the growth of algae. That is, this greenish organism that normally grow in water. If you put copper sulfate there, it will kill them, and you will not be able to grow them, and the water will be clean and safe for swimming. Now, uses of distilled water. Let us look at uses of distilled water. We use it in laboratory for preparing reagents and analytical work. For instance, you must have been to the laboratory before. You see sodium hydroxide, the teacher will say, go and make sodium hydroxide, bring hydrochloric acid, go and make sulfur nitrate solution, go and make barium chloride solution, and you work on it. All these reagents cannot be prepared with ordinary water, but can only be prepared with what? Distilled water. Because if you do that, other ions inside water will interact with the reagents, and that's not good for laboratory work. Also, in car battery, known as lead acid accumulator, the water we put inside the battery must be distilled water. If it is not distilled water, the battery will be weak. The battery will not have enough voltage and enough current in it. Then we also use in preparation of drugs to prepare paracetamol, syrup, tonic, blood tonic, and so on and so forth. We need distilled water for that. And it's also used in many other industrial processes that are too numerous to mention. Then, what about water supply to township? The water we drink at home. How do we do that? Well, let us look at something. The water we drink from the tap must be colorless. Imagine red water or brown water flowing from the tap. Will you drink it? Definitely not. Then the water must be odorless. If you are about to drink water and it's smelling like rotten egg, will you drink it? Definitely not. There must also be tasteless. That must have insipid taste. There must be germ-free. Although you cannot see this one with your eyes, but you can see it with microscope. If you have germs there, it can cause diseases. Then, and water must not contain dissolved particles. And the pH of the water must be appropriate. If the pH of the water is too much, you have stomach disorder. If the pH is too low, you have stomach disorder. Normally, the pH of water must range between 7 and 8.2 before it can be safe for drinking. Now, let us look at the processes for treating water. There are basically 5 processes, and they are aeration. Aeration means mixing oxygen with water. Coagulation means adding chemical substances to remove the dissolved particles inside. Sedimentation means allowing the dissolved particle to settle down. Filtration, that is, you remove solid substances from it. And disinfection, you kill the germs by adding chemicals. This is a typical water works, where water for town supply is treated. Here, we probably have here what is called an aeration tank, where the water is mixed with oxygen. Here, you have coagulation tank, where you add chemical alums. Here you have sedimentation. Here you have filtration, and here you have disinfection. But now, it might not be clear in this diagram. Let us look at another diagram. Let us look at this diagram. Here you have a motor. You have a fan mixing the water. See the water rising up and mixing with air and oxygen to kill the bacteria. The water is now pumped into a coagulation section as a chamber. From that, you add alum. Alum will coagulate it. Then at the same point, you also add lime. The function of lime is to regulate the pH. Then you pump the water into another tank, known as sedimentation tank. These brownish substances are the sediments that has been removed by the alum. Then you now allow it to go into a filtration tank. If you look at this filtration tank, you have a filtration bed containing gravels, sand, charcoal, and then you filter it. When you filter it, the water you have here now does not contain any solid particle. But then the water contains germs. What do? You add chlorine to it to kill the microorganisms. Then you add iodine. Iodine is a fortification. And then fluoride, also a fortification. What do? Iodine prevents goiter, while fluoride prevents tooth decay. In some countries, vitamin A is also added to give you good eyesight. And the water is now pumped into the tank, the storage tank. From the storage tank, it's now pumped up into a big tank up. And that one, the water now flow under pressure to your homes. Now, coagulation. What happens in coagulation is this. There is a substance we call potash alum, or simply alum. Most of us have seen it before. We use alum for so many things at homes. Normally we use alum to wash snail, right? To wash fish. Abi, that's in our homes. Then we have 2 forms of this alum. One is potash alum, the other is sodium aluminate. The potash alum is known as potassium aluminium tetraoxosulfate 6, and the other one is just called sodium aluminate. When they are added, they coagulate the soft particles, which means they allow them to clump together to form solid particles, and the process is referred to as flocculation. Then the next one is sedimentation. Iron causes the impurity to clump together to form dirt or flux. This settle down as sludge, that the brownish substance we saw in the diagram. The function of lime is to regulate the pH of the water. And then in filtration, we use fine sand, pebbles, gravels to do that. And charcoal can also help to decolorize and deodorize the water so that the water will not smell. And finally, this water work is in my library. You can see the filtration tank. There are so many other things there. And finally, ladies and gentlemen, that is disinfection. Chlorine is added to kill germs or microbes. Iodine is added as fortification, and fluoride. Like I said, iodine to prevent goiter, fluoride to prevent tooth decay. Finally, what have I learned about water? Please take your pen and take 20 seconds to write what you have learned. Now, attempt this question. Why is water referred to as a universal solvent? List the two elements that constitute the compound water. Give two evidences that support your answer in question number 2. Mention any two physical properties of water. State 4 different sources of water. State 3 uses of distilled water. And we have come to the end of the lesson for today. Next time, we'll be discussing hardness of water. And I'm giving this one to you as an assignment. When you get home, make sure you read the topic, hardness of water, so that you can have a wonderful experience next time when you meet. Thank you.
Thank you, sir.